have our connection designed, we're going to analyze it to see if it works. So we're going to move to the Analysis tab. Here you will find very helpful information. So first of all, in our case, we have loads and load cases in forces at the end of the bars, because we have imported this model from CYPE and we previously analyzed this structure, so this information we haven't inserted, but one without coming from CYPE could have inserted this node manually, and they could have inserted the load cases manually too. So that would have been done by creating here load cases. So add a new load case, and you could just give it a reference and say if it is acting, and then you will have that load case here in loads, not in the bearing element, but in all of the other ones. So you will be able to fill up these forces for each load case. We do get some questions sometimes. The support team get some questions sometimes, and that is why, if I brought it from CYPE, we don't have any forces at the end of the bars. That could be fixed by clicking here in Generate from the BIM model. So this is reading from your CYPE BIM model the forces, and the answer could be that these minimum values are set by default, and maybe you have lower forces than this, and that's why they're not getting imported. So if that's ever the case, please remember to set this to 0, 0, so all forces, regardless of how small they are, get brought from CYPE. Here is to select dissipative elements. So sometimes in some countries where the seismic force is very relevant, then we have to analyze this connection, taking counting with some of the elements being dissipative elements, so we can actually reach the end of the analysis. So here's the operation to set that. Here are the design options where one can fix the discretization size, the length to calculate the average stress of the welds, and the backline, if we do perform the backline analysis, the number of modes. And the next would be the three analysis options that we have. So we could run the stress and strain analysis, the rotational stiffness, which, by the way, if you do want to run the rotational stiffness of connection, you have to make it here, activate this option and fill up the load cases for the rotational stiffness. Those values from the rotational stiffness can then be exported back to CYPE, because at CYPE, whatever we could have selected that the ends of the bars were pinned or fixed, and they could be something intermediate. So that could help, that rotational stiffness analysis could help you determine the exact fixity coefficient for the end of the bars. And then the backline analysis. So we're just going to run for this training the stress and strain analysis for this connection and comment on some of the results. So the analysis is ran by OpenSys, the analysis engine developed by the University of California, and it will provide us with first the maximum demand capacity ratio. We can see the elements displayed in colors, and these bolts in this case would be the ones that are more solicited. So here we see the results on these sections. We can, if we click on this window on sections, here we will see the full code checks for the run for the sections. Then the plates, we can see we can actually choose to only show the failed checks, so we can see what's going on. So here we see for the bolts which are related to the plates, and that's why it's being shown. They have some distances between centers that they're not complying with the checks. And here we will have that same information, so we can go step by step asking for the code checks run for the welds, the bolts, the plates, to see what's wrong with them. This is just the maximum demand capacity radio, but if we ask, for example, for the equivalent von Mises stress deformation, we can see this type of results. We could actually change the log case to see it for each log case. We can consult the displacements and the von Mises stress again. When we want to see the full code checks of the connection entirely, but not in step by step, we can click here on checks, and this will provide us with the full code check report. Also the summary of, we could create a report, for example, with the loads, the connections components, and the checks. And one thing we haven't commented that it's new from 2025 version point D would be the ability to snap images that can be inserted into the reports. So let's say, for example, that these bolts that we have, it's a matter of, it's nothing of tension or von stress, but it has to do with the distance between the centers of the fasteners in the one direction and the other. Maybe if we, instead of 75 here in the bolts, we choose that in the X direction, in the Y direction, we have, let's say, 60. Let's try 60 minus 60 and minus 60. Now they are a little bit closer to each other and further from the P1 flinches. Let's run the analysis again and see if they comply with the checks. Okay, so now no of checks I have failed. Everything's working fine, and we were speaking about the images. So let's say, because I want to add this snapshot of the von Mises equivalent von Mises deformation, then I say capture image and I save it with this name, which is usually what result are we consulted and for which load case, and we say accept. And here in the library of snapshots, we will see in which type, which reference we have, and that can be inserted when asking for the summary and asking for this stress and strains. We will be able to insert some snapshots of the results that we consult here in this results area.